Welcome back. Today we're doing a little bit of alternator testing. This is a alternator for my Jeep. It's actually a Denso alternator with an external regulator. Easily to identify with these two terminals and no connection whatsoever to the rest of it. That goes straight to the brushes. We may show that later when we take it apart or look inside. And obviously this is the output, and the ground is just the casing here. What we have here, we've got I'll take the camera over and handheld it so we can go to each device. So just a brief overlook over the setup here. So we got the alternator, we just used that big diameter and a poly V belt on the mill. Mill runs at 1500, that's probably about just over 3000 I think. Which is okay. It should get the full power at this stage. We feed, because we don't have the car available and the ECU will not control this input. We do that with a power supply here. We also have a voltmeter. The battery it's an old battery. It's not the very best one. So the battery voltage is 8.3 volts at the moment, and we have an amp meter here. And when we run the thing, it may be a little bit noisy, so I tried to explain it before. When we run the thing, I crank up the voltage on the excitation here, and we should see the voltage here increasing, also the amps increasing. So let's fire up the mill. At the moment we have no excitation voltage, so if I crank that up slowly, we can hear the noises changing, and the nominal charging voltage is 14.4 volts. If we check our amp meter, it's about 15 amps. That's about what the battery can take. So let me take the camera handheld and I'll show you around. So essentially the first test is already done. The bearings sound okay. I'm gonna check that with the screwdriver and listen to it, but they sound good. Again, excitation voltage goes here, output is here, ground to the battery is the casing. We have our power supply here, which we just crank up to about 7 volts or so, and then it should actually draw some current. We have our voltmeter here, and the drive setup looks like that. It's just the outer diameter of that flange where I normally mount my my chuck. The alternator itself is just hole with a 1, 2, 3 block here and a bolt through in the mill, in the vise of the milling machine. So pretty simple setup. Ground for the battery goes off here, plus goes up here via the amp meter, and if you fire it up again, the battery has already taken some charge. Let me discharge that battery a little bit. I use one of these battery testers which draw 150 amps, so we can drain the battery. I'll just do that and come back. So we drained down the battery a little bit. Let's fire up the mill. So you're running at about 3000 RPM on the alternator, and we can see there is no voltage coming out. As soon as I crank the excitation up, you can hear the sound. We can hear the sound is changing of the alternator, and so that's about maximum. So if we go to our ammeter, we're doing just over 10 amps, which is what the battery can take. Voltage looks fine. I can drain that a bit further, and we're running at what's that? Just 8 volts or so at 1.2 amps. That's about right for that alternator. It's a 120 amp alternator, and that's basically how you test an alternator. If you run one, let me stop that. If you run an alternator with a built-in regulator, you don't need the extra excitation. Just connected to a battery. Do not run an alternator with nothing connected, you may destroy it. So what we know now is the alternator basically works. We're happy with it so far. And these Denso alternators, they usually suffer from poor brushes, so we take the back cover off it and replace the brush part. It's just a little spare part you can buy. Once we fitted that, it should be good to go. That rattling is just the power supply cover. So as we can see, the battery stays at 11.5 volts. If we drain it again, so we drained it a little bit, it just comes back. So let's fire up. Excitation is 0, so let's fire up the mill. And as we can see, the voltage does not increase because we have no excitation. So if I crank the excitation up slowly, we can hear the sound is changing. Now we are about 14 volts and we are drawing 15 amps. And do a bit higher. So yeah, that's almost 20 amps, so that's fine. And as you can see, we can regulate the voltage with the excitation. More excitation means more charging voltage, and that's exactly what the ECU in your car does, or the regulator if you've got a built-in regulator on your alternator. It's pretty simple. Yeah, if I back off, the battery comes down. It's just a poor battery, it doesn't take a lot of charge. So if we use a pretty empty one, a good one, would possibly be able to draw a lot more. We shouldn't go much further than 15 volts, because otherwise the battery starts gassing. 14 volts is about right. And everything sounds good. No nasty noises coming off the alternator, which is the most common fault, that the bearings are poor. Let's just check them. All we use is a simple screwdriver, and just listen to your screwdriver, and obviously the front bearing is here. All I can hear is the rumbling of the mill. Alternator looks fine so far. I couldn't feel any play or any strange spots when I turned it by hand. So there's not much more to say. Any questions, let me know, I'll try to answer them. The reason why I pushed the button here is because the nominal range is 600 amps, so you won't see anything. If you press the button, it's 30 amps full range in one direction. That's the reason why I had to push the button. Just to explain that. And if the alternator on standstill, never run excitation, because you may cook the rotor. Because again, these two terminals go straight to the brushes, and that will feed the windings in the rotor. And if there is no movement and no airflow, it may cook. So don't do it. Be careful what you're doing. And if you don't know what you're doing, just don't do it. I think that setup is pretty much against any health and safety, so this is just for entertainment. It's not instructional. That's one of these little brush boxes. You see the brushes inside here. Just here you can see the brushes. If you take them out and the brushes don't go at least a quarter, if they new, they go right to the center, but if they don't go at least for a quarter, I would recommend to replace them, because I think I can't remember what they are, but probably about £5, $7. So it's too cheap to leave it in if it's already worn, because it's a bit of work to get the alternator out and take the whole thing apart, make sure everything works, and then put it back together. I'd rather do it before. This alternator is used. I bought it off eBay in unknown condition, and even if someone tells me it's working, I don't believe that because it was so cheap. Don't know. I think I paid a tenner for it. Knowing the fact that it might need repairing, but it looks okay to me. It's got a slightly bigger pulley because these larger alternators run with lower speed, so should even last longer on the bearings. Anyway, let's take it off and take the back cover off and look inside. So taking the thing apart is pretty simple. You need I think it's 12 or 13 millimeters. Take these 10 millimeter nut off, which holds the cable, and there is another one underneath which holds that plastic part. It's 12 millimeters. Just get that out. Here it is. And then we need to take those little bolts out. Yeah, it's actually nuts. It's 8 millimeters. It's all metric because these are Japanese alternators, so just take them out. And this one needs to come out as well because that's the ground one. That's a little bolt, 8 millimeter head as well. And then this thing should come off. It's a tight fit, but it usually comes off. Here we go. There is a rubber thingy which seals that against moisture, and that little, no, I know what it was. There's a little metal thing. It's this little metal thing which sits here on that bolt, and the nut goes here. The nut goes here, the bolt goes here on the cover. It's just grounding that cover. So again, make sure it's all clean. It doesn't look bad. There's not a lot of carbon grind. That looks good. So to get the brush box off, you just need to look at the bolts. I can't remember it. I've done it a while ago, but I think it's those three. These screws are a bit of a pain. You need to have the right size screwdriver, and that's one of the reasons why I left it in the vise. It makes it so much easier to put some pressure on. If it's the wrong size screwdriver, just remember which bolt goes where. I think they're not all the same length. Let's leave that here for a second. These are the same. These two are the same. They got round heads, and I think that's the last one here. It comes out. Yeah. Okay. So I think that's a hex head. No, it's a short round head as well. And then you should be able to pull the thing off, and as you can see, hopefully you can see some light here. So if you compare the old and the new one, we can see a typical wear pattern for that alternator. I don't know why the inner one is always worn more than the outer one, but that's actually the case. When you put this in, there is a little trick I'll show you later. We just replace it. There is not much travel left here on that one. If they knew, they go to the center and it's at least 1/2 down. I don't know how many miles that thing I've seen, but the more concerning factor, I don't know if that's visible enough, is that the inner one, the front one, is more worn than the outer one. But again, this is a very common pattern. I've seen that many times on these alternators. So let's check how the slip rings look. Yeah, that inner slip ring. That inner slip ring is badly worn. I think we need to take it apart and skim it over, because I don't know if that's visible enough, but because the rear one was worn so badly, the pressure was lower and it was firing, and that was burning down the slip rings. So we need to take it apart and just do a quick skim on that. I may show that in a later video, but the trick I wanted to show is, if you put those brush boxes back, just retract them, use a piece of cardboard, that's probably a bit too big, just make it smaller, and slide it over the slip ring so you don't actually destroy anything here. So just pull them back, and then you can so once you're done, just push them back, get it over it, move it in, and then pull the cardboard out. That makes it that makes your brushes lasting a lot longer, because you don't kill the edges. I tried to get a shot from that worn slip ring. We'll see if that works. So here we should be able to see the wear. This is fine, but here it actually grabs my fingernail. So, and it's very uneven. Typical issue if the brushes are worn and the alternator has high demand. That means a lot of current is flowing there. Or the thing was driven in dirt, mud, whatever, and I was wearing it down. The thing is that the cover I was talking before, the cover does not show a lot of grind. So it either someone has already looked into it and decided it's a no-go, or it just is as it is. So what we're going to do, we take it out, we take the rotor out and skim the front slip ring. There's no reason for doing the back one, because that's absolutely smooth. We just go over it with a bit of emery cloth, just make that smooth, take as little as possible material out, because there is not a lot of copper on these things. I don't know exactly how much it is, so we'll see. To take it apart, you just take the bolts out and then just smash it out. I probably leave the front bearing and the pulley, everything in place. There are centers, so I can do it between centers, and then skim it down. This should conclude this episode of the alternator inspection and repair. I may do a reassembly later on. I'll film it, I just don't know if I can find the time for editing. But essentially that explains pretty much everything. The rest is common sense. Just put it back together as you took it apart, and the testing was explained before. Any questions, let me know in the comments and I'll try to answer them as best as I can. Thanks for watching. Thanks for subscribing. Until next time.